Hi, this video is going to go over problem 10 from the review exercises. Here x is a continuous random variable with a probability density function given by f of x equals 2 over 1 plus x quantity squared for values of x greater than 0. So we are going to start by sketching the probability density function. So let's see. Start here, 0, 1, 2, 3, 4, and so on, and 1, 2, 3. All right, so here's going to be our f of x, and here's going to be our x, and when x is equal to 0, we can see that f of x is 2, and we're going to end up having a function that, as this cubic function, is going to be sort of decreasing here. When x is equal to 1, right, we get 2 over 1 plus 1 is 2 cubed, so that's going to be at 1/4. And so we're going to have this function that's going to kind of like go like this. So that's basically what our probability density function looks like. Part B asks us to find the cumulative distribution function for x. So for part B, remember my cumulative distribution function I find by integrating from the smallest possible value of x up to sort of x, my probability density function, 2 over 1 plus x cubed, and I'm going to put in a, because I'm integrating to a limit of x, I'm going to put in a t here instead of an x, dt, which is going to be equal to x squared plus 2x over x plus 1 squared once I integrate and evaluate. So that's going to be sort of my f of x for values of x that are greater than, let's see, greater than 0, and it's going to be 0 for values of x that are less than or equal to 0. So there's my cumulative distribution function. Now part C asks me to find the probability that x takes on the exact value 3. And keep in mind, whenever I am working with a continuous random variable, the probability that that random variable takes on any individual particular value is always equal to 0, because there is no area under the curve at one exact point. So that's an easy one. For D, if I want to find the probability that x is less than 3, I can use my cumulative distribution function to do this. The cumulative distribution function tells me the probability that x is less than or equal to a particular value, but since the probability that x is equal to 3 is 0, this is the same as my cumulative distribution function evaluated at 3. So that's going to be 3 squared plus 2 times 3 over 3 plus 1 squared, which gives me 15 over 16. If I want to find the probability that x is between 2 and 3, I can take the probability that x is less than or equal to 3 minus the probability that x is less than or equal to 2. I know that f, my cumulative distribution function evaluated at 3, I just found is 15 over 16. If I subtract off capital F of 2, subtracting off 2 squared plus 2 times 2 divided by 2 plus 1 squared, which gives me 15 over 16 minus 8 over 9, which comes out to about 0.0486. So there would be my answer. And then part F, given that the random variable takes on a value less than 3, so given that x is less than 3, find the probability that the random variable takes on a value greater than 2. So keep in mind, for x to be greater than 2 but less than 3, that means that x has to be greater than 2 and less than 3. And I'm going to divide that by the probability that x is less than 3. These are the two answers that we just found. Probably that x is between 2 and 3 was 0.0486, divided by the probability that x is less than 3 was 15/16, and that gives us an answer of about 0.0519. And that is the solution to problem 10.